the YouTube link also. Is it live?
Yeah, it is actually.
Okay. Before we start our session, I would like to thank you, man. Like, yeah, it is live. Before we start
Mm.
the session, I would like to thank you because you made those uh, presentation, which is quite really helpful, and the videos which you guys have already shot, like which you have already uploaded on YouTube, quite really helpful to understand the basics and to understand like how everything works in DBMS.
That's good. I'm glad it's helping you, and that's the main
Yeah,
reason because at the time of exam we can't read the whole book, right? And the book has so
yeah,
much
yeah,
of stuff that not everything makes sense. So breaking it
yeah.
down, making it into small pieces is really helps, especially at the time of examination.
Correct. You're right.
Cool. We will connect tomorrow also for preparing for the next set of examinations. We'll keep two sessions, or probably just one session to begin with tomorrow. Maybe at the same time if everybody is comfortable. Maybe we can start a bit early, like 9 o'clock or something, 9 p.m. And then
Mm-hmm.
break it into two parts. One for the algorithm, and second is for the which is the other subject we're doing.
Java.
Java, yeah. So we'll break it into two and we'll start preparing sooner the better because those are the only two exams after that semester is over. And I'm pretty sure not everybody is going to continue with the other years. So that's those 5 days or 6 days. What we're going to have is going to make a lot of difference if we put in effort. So
Mm-hmm.
yeah, enough of talking for myself. I think let's get started, and then tomorrow we'll probably have some time to talk.
Sure, sure.
Okay, so I'm gonna share my screen, and what my plan is that we start with a bit of a theory first because we get tired of speaking, and then we do the um, problem solving. So we relax a little bit. Again, we do some theory, and that way we won't get too much tired. Okay, so let's open the database management system, and we're gonna just start with a question paper first. And we'll start this time from the bottom because we didn't spend enough time yesterday on the last few questions. So we'll start with that, and then we'll slowly progress um, upwards. Okay, so first question is where is it? Yeah, data mining. So and data warehousing. I thought of doing these guys together because these are interlinked. First, I'll just give you brief information of what they are, and then we'll go into. So this is the pattern I'm going to follow with most of these questions. I'll give you brief information, and then we'll get into the actual slides, so that at least you're familiar in simple words. So we store the data into database. Like for example, I have this different database tables created. Um, and we usually use it for different websites where we need the data, and we fetch the data and we show it to the user. So that's basically the reason why we store the data. But sometimes when we are dealing with the large business, the business also wants to go ahead and analyze how the behavior of the user is. And for that purpose, of course, they're not going to be working on the live data because live data would mean that new users would be coming and new data will be added. So they don't want to touch that. So what they do is generally take a copy of it, and then they have a dedicated team which basically goes ahead and um, works on that data, stored data, which probably gets updated not every day, but maybe a week or periodically, basically. And then they use that data for analyzing and improving their business. So this data, when it's used for this purpose of analyzing etc., their user behavior for improving business, this is called data warehouse. Okay. And the process of analyzing and checking users pattern, customer buying pattern, etc., like which product page they're going on, etc. So that this analyze that we do, analysis that we do, that is called the data mining. Okay, so now we'll get into the slide. I think with this help of information, you'll be able to easily explain in the examination, but we'll look at the content also. So data warehouse is a database system that is designed for analytical analysis instead of transactional work. So what we normally do is transactions. um, on our website, but here we're going to solely use it for analysis, and that will be the data warehouse. Data mining is the process of analyzing the data pattern. So that data is called data warehouse, and the process is called data mining. Like I explained earlier, data is stored periodically in data warehousing, and analysis happens regularly. Data warehouse is the process of extracting and storing data to allow easier reporting. So we extract the data, we save it, we store them, so that we can easily report whatever the issue is. What's somebody written this?
Yes. Yeah. Yesterday you asked me to make a story out of it.
Oh, okay. I'll love to hear that story. I'll love to hear that story. Just in a moment.
Yes.
Thanks. Good to go. Okay, so data mining is okay, sorry. Data mining is the use of pattern recognition logic to identify patterns. So we're going to identify the user's pattern. Like, for example, one particular user is always buying a specific product, so that particular user might have a need for it. Do we have similar users who are buying that product as well? So that pattern recognition is done. That's the purpose of data mining, and purpose of warehousing is to extract and store it for easy reporting. Managing authorities, who manages this data? So data warehouse is managed, carried by warehousing is carried by the engineers, which means the storing of the data, extraction of the data for this purpose is done by engineers. The data mining is carried out by the business users with the help of engineers. Data handling, data warehousing is the process of pooling all the relevant data together. Data mining is considered as a process of extracting data from large data sets. Uh, Subject oriented, integrated, time varying, and non volatile constitute the data warehouse. So, this is a functionality of that, which is subject oriented, integrated, time varying, non volatile. This constitute data warehouse. And artificial intelligence, statistics, databases, machine learning. And there's pretty powerful words you can use in the examination when it comes to analyzing any part of data, all used for data mining technologies. Then what's the task? Data warehouse is the process of extracting and storing the data in order to make reporting more efficient. And pattern recognition logic is used in data mining to find patterns. It's just a repetition of whatever we've discussed. It extracts the data, stores in orderly format, making reporting easier and faster. Again, repeating the same thing. This procedure employs pattern recognition tools to aid the identification of the access pattern. Examples could be useful. When a data warehouse is connected with operational business systems like CRM, customer relationship management, it adds value. Data mining aids in the creation of suggestive pattern of key parameters. Customer purchasing behaviors, item sales are examples of this. As a result, business will be able to make required adjustment to their operation in production. So just quick recap, we already discussed what they are. Just few more pointers from here. Solely carried out by engineers. This is carried out by business and engineers. This is the process of pulling all the relevant data together. This is the process of extracting data from large data sets. Then, yeah, this is the process of extracting and storing data in order to make reporting more efficient. This is used for to find patterns. Example is when a data warehouse is connected with operational business systems like CRM, it adds value. And here, uh, data mining aids the creation of suggestive patterns of key parameters like customer purchasing behavior, item sales are examples. Okay, yes, I'd love to hear what story you made, Kritika.
ओके तो मुझे इसमें ज़्यादा स्टोरी बनाने की ज़रूरत नहीं पड़ी क्योंकि
Okay.
वी ऑलरेडी आई मीन इफ़ यू रीड डेटा वेयरहाउसिंग एंड डेटा माइनिंग हमें इफेक्टिवली पता है कि वो क्या करता है इट्स सॉर्ट ऑफ
Hmm.
लाइक व्हाट यू डू फॉर अस
Hmm.
I started with this that you
Hmm.
bring all the data together in one place in a PPT and then we
Hmm.
analyze it regularly and then
Hmm.
and so basically you are data warehousing and we are data mining. Okay.
Okay.
and then पर मतलब आई थिंक इसमें मेन प्रॉब्लम जो मुझे याद करने में वो याद आई थी कि आई डोंट रिमेम्बर द पॉइंट्स एक के बाद एक. So
Okay. Okay.
I decided that I'll answer these five questions: what,
Hmm.
when, why, and who. So,
Okay.
pehla point is what is it? Warehousing is a database system. The first
Hmm.
point here. Database
Hmm.
system designed for analytical analysis. What is mining? It is a process of analyzing those patterns.
Hmm.
When is it done? So over here,
Hmm.
in warehousing, it is stored periodically, and data
Hmm.
mining, it is analyzed regularly.
Yeah.
Now, why is it done? Third, seventh, and eighth point is literally the same thing. So
Yeah.
it's because it allows easier reporting, and data
Mm-hmm.
mining is for pattern recognition. Who
Yeah.
does it? Imran is the engineer, and we are the business users.
Okay. Fine.
Okay. And functionality. Uh, yes, we remember functionality and examples differently. Like
Okay.
functionality at this point and example. We talked about this.
Okay. Awesome. This is brilliant. This is amazing. Well done. Nice. So yeah, at least even I had challenge in of course I know all the points, but I have also
Hmm.
challenge in remembering in sequence. But yeah, what, when, why is definitely going to help us remember it. That's pretty good. Okay, moving
Yes.
on. So we did two of them. That's great. We'll jump on to the NoSQL database. So if I had to tell you, first you have to tell what database is. So in the definition. So of course you can start with like NoSQL databases are is a database basically, which is used to store the data and retrieve the data, but it does not have the relational system like the RDBMS. Okay, so let's, and then data is stored in form of objects in form of JSON, so it's easy for us to query, especially when you're using object-oriented programming. So let's go and search no SQL. Okay, so NoSQL, non-SQL or non-relational, some people call it non-relational also, is a database that provides mechanism for storage and retrieval of data, like I said, uh, in means other than tabular relations used in relational databases. So you just have to add to that. So just explain what a database is, which is usually mechanism of storing and retrieving data, and then just explain this non-relational part, which is it means other than tabular relation, which means tabular relation is not used in this type of database like we do in the relational databases. So tables won't be formed. So usually in JSON format, etc. So in a NoSQL database, a book record, for example, is usually stored as a JSON object. For each book, we'll have ISBN, which will be the ID, book title, edition number, author name, author ID, are stored as attributes in a single document. So then you can explain, you can give example of a JSON document stored in a single document. In this model, data is optimized for intuitive development and horizontal scalability. So you can talk about this point. I think this is pretty useful. That data is optimized for intuitive development and horizontal scalability. Okay, there are different types of NoSQL databases. One of them I have worked with is MongoDB, but I'm telling you very specific. But in generic, the type of database are key value, where the data is stored in key value pairs. They're highly partitionable, allow horizontal scaling at scales that other types of database cannot achieve. Document type of database, in application code, data is represented often as object or JSON like document because it's very efficient and intuitive data model for developers. Graph database purpose is to make it easy to build and run applications that work with highly connected data sets in memory. Gaming ad applications have use cases such as leaderboard, session stores, and real-time analytics. And there's too much jargon going on. We have to break it into keywords. So key value databases are highly partitionable and allow horizontal scaling. So there's two keywords from that. In application code, data is represented often as JSON-like document. So we can pick up that. So when you talk about document, you can think about JSON like document. Just to show you quickly, JSON data in no SQL example. Say this. So it's in JSON format, key value pairs. Okay, so that's a document you're talking about. You're talking about key value. Then graph. Graph database purpose is to make it easy to build and run application that work with highly connected data sets. Okay, in memory gaming and ad tech application have use cases such as leaderboard, session stores, and real-time analytics. Okay, I want somebody else to read it. Ashish, you want to go?
Yeah, sure. Thank you. So the NoSQL is like non-SQL or non-relational database. It's a database that provides a mechanism for storage and retrieval of data. It means like it's a other than the tabular relations used in the relational database. It's different
Okay.
than the
Now,
tabular structure.
yes. While we are going through, while Ashish is reading it, I'd like everyone to just pick up one point. Forget the all. I mean, of course, you hear whatever is being read, but just try to remember at least one point. So now, after we are done, I'll hide all the answers, and then we will just talk about one point that we picked up from this, and just say that loud. And when others are giving, then listen to their points also. So that, and then we will shuffle. We'll kind of we'll do a next read, and that time you pick up another point, and somebody else will pick up another point. Okay, we'll try something like that. Yeah, go on.
Okay. In non-SQL database, a book record, for example, is usually stored as a JSON document. For each book, the item, ISBN, book title, edition number, author name, and the author ID are stored as an attribute in a single document. In this model, the data is optimized for intuitive development and horizontal scalability.
Okay. Of course, if I tell you all to pick up one point, two people might pick up the same point. So it's better I put names here. So Ashish, you can pick up this first one. It's a big one. I'll give it to Sumaya. This can be picked up by Sajjan. Sajjan, you're there, right?
Yes,
I
I'm
can take.
here. Yeah.
Okay, good. I can take this one. Pritika. Is somebody else there, or is that all? Okay,
I think that's all.
I'll take the last one. One more. Uh, okay, we'll start again. Ashish, just start again once again, so everybody's focusing on their own points also.
Yeah, sure. So NoSQL, that's a non-SQL or non-relational. It's a database that provides a mechanism for storage and retrieval of data. It means other than the tabular relations used in relational databases. In a non-SQL database, a book record, for example, is usually stored as a JSON document. For each book, the item, ISBN, book title, edition number, author name, and the author ID are stored as attribute in a single document. In this model, data is optimized for intuitive development and horizontal scalability. The types of non-SQL databases. The first one is the key value pair. The key value database are highly uh, partitionable and allow horizontal scalability at scales that other types of database cannot achieve. Document. In application code, data is represented often as an object or JSON-like document because it is an efficient and intuitive data model for developers. Graph. A graph database's purpose is to make it easy to build and run applications that works with highly connected datasets. In memory, like gaming and ad tech application have use case such as leaderboard, session stores, and real-time analytics.
Okay, so I'm gonna hide it now, and we have to give our points.
Yeah,
Okay, let's start with Ashish.
yeah. So the non SQL is a database which provides an like a functionality to store and access the data.
Hmm.
It means like it provides a non-tabular format of the data
Good.
to store the data. Yeah.
Very good. Awesome. Okay, next.
Yeah. So types of NoSQL database, key value. Key value databases are highly partitionable and allow horizontal scaling.
Very good. Very good.
Yeah.
Sajjan. Okay, next person. Sumaya.
NoSQL databases are usually in the form of JSON documents.
Mm-hmm.
So, for example, if you're storing book data, then the attributes of the book, like book title, author, um, book
Author
ID, are
ID.
stored as attributes.
Yeah.
They're stored as attributes as in key value pairs.
Okay. Okay, good. Kritika.
And one of the types of SQL database is graph, and
Hmm.
with graph, it makes it easy to build and run applications in a
Mm-hmm.
highly connected data set where it is
Good.
highly connected. Yes.
Okay. Two other types are, one is document and second is in memory. And in document, in document code, in application code, the data is stored in form of JSON, and that makes it easier for the developers to efficiently access that data. And the other one I mentioned was in memory, where the data is actually used for in gaming applications as session storage, etc.
We have one important point we have missed. Like data is optimized for the intuitive development and it's horizontally scalable. That's the most
Yes,
important thing, I guess. Yeah. Horizontally scalable is like some of the database doesn't even support it.
correct, correct. Scaling is important. I agree.
Yeah, the scalability.
Perfect. So let's do a like a shuffling. So this goes to me. This goes to Kritika. I'm gonna give you a difficult one this time.
That's okay.
Um, okay, Sajjan, Ashish, you'll take two this time.
Yeah, that's fine.
And okay, yeah, let's leave it that way. Okay, so I'll just give a recap and just pay attention, and then we can hide the question. Sorry, answers. So NoSQL is a database that provides mechanism of storing data and retrieving data in means other than tabular relations used in relational databases. In NoSQL database, a book record, for example, is usually stored as a JSON object, as a JSON document. For each book item, ISBN, book title, edition number, author name, author ID are all stored as attributes in a single document. In this model, data is optimized for intuitive development and horizontal scalability. Types of NoSQL database, one is key value. Key value databases are highly partitionable and they allow horizontal scaling at scales and other databases cannot achieve it. Document, in application code, data is represented in form of an object in JSON-like document because it is efficient and intuitive data model for developers. A graph database purpose is to make it easy to build and run applications that work with highly connected database. So main thing to remember is that especially highly connected sets, when you work with that, using a graph database is really useful at that point. So the keyword is highly connected database. Data sets are which are connected strongly. In memory, gaming and ad tech applications have used use cases just leaderboard, session stores, and real-time analytics. Okay, I'll start with the first. So, NoSQL database is a database which has a mechanism to store and retrieve data, but other than the tabular form which is used in the relational databases. Next one is Kritika.
Yes. So, for example, if we want to store a book record, that includes author name, edition name, ISBN number, etc.
Mhm.
Um, if we can do that with NoSQL databases, and
Yes,
it allows intuitive development and
yes,
horizontal scaling.
very good. Okay, so there are different types of data. So give me one of them, Sumaya.
Key value, the data is stored in key value pairs, and um, it provides a horizontal scalability at scales that other databases cannot achieve, um, and it's highly partitionable.
Very good. Okay,
Yeah,
Rajul.
data is stored in a JSON file format, as it is a one of the efficient way. Yeah.
Hmm. Just Sajjan was like, before he was going to say sir, he just said, I jaldi bolo, नहीं तो भूल जाएगा.
Actually,
Before even I could call his name, he just gave his answer, जल्दी निकलो, बाहर जल्दी निकालो. कल इसी तरह करना, ठीक है? एंड तक
uh,
स्टूडेंट होते हैं, एंड तक पढ़ते रहते हैं, और एग्जाम में जाके जल्दी स्टार्ट करो मैडम, सब उड़ेलना है, वो भूल जाएगा. Okay. Right. So next one up was
Graph.
graph. Yeah, Ashish.
Yeah. When you are working with the highly connected data sets,
Very good.
the graph provides you the efficient way of storing the data.
Very good. And the last one was in memory. So
Last one, yeah, yeah,
gaming and
yeah,
ad tech applications use it for use cases such as leaderboard, session storage, and what was the last one? Session storage and analytics, right?
analytics,
Real time analytics. Yeah.
real-time analytics.
So we did NoSQL database, which is great. Advantages of NoSQL databases. This is not the question in the paper, but it's there in the um, assignment. So let's do that. Flexibility. NoSQL databases generally provide flexible schemas that enable faster and more iterative development. The flexible data model makes NoSQL databases ideal for semi-structured and unstructured data. Scalability. NoSQL databases are generally designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. Some cloud providers handle these operations behind the scenes as a fully managed service. High performance NoSQL databases are optimized for specific data models and access patterns that enable higher performance than try accomplishing the similar functionality with relational databases. Highly functional NoSQL database provide highly functional APIs and data types that their purpose is to build for each of their respective models. So let's just break it. Provide flexible schema. That's one. Enable faster and more iterative development. Okay, and ideal for semi-structured and unstructured data. Scalability designed to scale using distributed clusters of hardware instead of scaling up by expensive robot servers. Some of the cloud, okay, I'm not going to go into the detail of that. High performance are optimized for specific data models and access pattern that enable higher performance. We are not going to spend too much time on this. Reason for this is because if you don't have that much time, and second is that even if advantages come in for NoSQL database, there are a lot of content here that we've spoken about which we can reuse. If we just remember these points like flexible, scalable, high performance, high functional, we kind of reuse some of the information from here like data is optimized for intuitive development, horizontal scalability. We can give some of the examples in some of these points. So I think we can really make up this answer. We have to do some of the skips, otherwise we won't be able to cover everything. Okay, so NoSQL will provide highly functional API. Yeah, this could be useful. And data types that are purpose. Okay, cool. So I want somebody else to read it. So maybe Sajjan, you want to try? Sajjan there or?
Sure. Yeah. Yes. Yes. Okay. Advantages of NoSQL databases. Flexibility. NoSQL database generally provides flexible schema that enable faster and more iterative development. The flexible data model makes NoSQL database ideal for semi-structured and unstructured data. Scalability. NoSQL databases are generally designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. Some cloud providers handle these operations behind the scenes as a fully managed service. High performance. NoSQL databases are optimized for specific data model and access pattern that enable higher performance when trying to accomplish similar functionality with the relational database. High functional, highly functional. NoSQL databases provides highly functional API and data type that are purpose built for each of their respective data models.
Yeah. So their APIs, of course, can return data in JSON format, and that could be useful when using it with object-oriented programming. So key things to remember is flexibility. They have flexible schemas, uh, faster development because of that. We talk about scalability, so it scales horizontally. Uh, High performance, and they're optimized for specific data models and access patterns. Enable higher performance. They're highly functional because the API they provide and the data type they provide are built for these data models. Okay, moving on. Locking in transaction. So transaction is basically a single unit of work in database. And the problem with the concurrent transaction, which means when two different transactions occur at the same time on the same data item, there are certain problem that occurs. For example, if one transaction is trying to modify the same data item, uh, in the middle of its modification, the other transaction comes, it reads that information and tries to modify it, so there can be clash in that. So there are a lot of issues. So to solve that problem, there's a term called locking. So in locking, what is really used to solve the problem of concurrent transaction, and how it works is that um, when one transaction wants to make a change or manipulate one particular data item, it goes to the what is the control manager? What was the name? I keep forgetting. Can somebody remind me?
Concurrency control manager.
Yeah, concurrency control manager. Okay, so we grab that word from the concurrent transaction. Okay, concurrency control manager. Yeah, it goes to the concurrency control manager and says that I want to place a lock on this data item. So the concurrency control manager checks that are there any other transaction who is already processing or manipulating that data item, or have any other transaction placed the lock on it already. If they haven't, it'll be granted. The request will be granted, and that transaction will start um, manipulating that data, whatever it needs to do. And during this process, if another transaction comes to concurrency control manager and says that I want to also work on the same data, the request will be denied because the lock is already been held by another transaction which is already working on it. So until unless that lock is released, uh, other transactions cannot take the lock. So that way, only one transaction will work on a one data item at a time, and that way there won't be any problem of the concurrency transaction. So that's locking basically. So let's move on to the slide quickly. Okay, I'd like Kritika to read this.
Why there is a double star?
Anything you have a double star is actually in the question paper, and it's probably also in the assignment, so it's more important.
Okay.
Okay, I'll
Could
read.
you, yeah.
Locking protocol.
Hmm.
Locking is a technique used to lock or restrict some data in a database so that only one database or user session may update that particular data. This prevents two or more database users from updating the same exact piece of data at the same exact time.
Yeah.
A lock can be placed by a transaction on a shared resource that it desires to use. When this is done, the data item is available for the exclusive use for that transaction. That is, other transactions are logged out of the data item.
Okay.
When a transaction that has logged a data item does not desire to use it anymore, it should unlock the data item so that other transactions can use it. If a transaction tries to lock a data item already logged by some other transaction, it cannot do so and waits for the data item to be unlocked. Yes, all log requests are made to the concurrency control manager.
It's called
Uh, transa-
concurrency.
Concurrency control manager.
Yeah.
Transactions proceed only once the log request is granted.
Yeah.
For example, assume that two people who go on an electronic kiosks at the same time to buy a movie ticket for the same movie and the same show time. However, there's only one seat left for the movie show in that particular theater. Without concurrency control in DBMS, it is possible that both moviegoers will end up purchasing a ticket. However, concurrency control method does not allow this to happen. Both moviegoers can still access information written in the movie seating database, but concurrency control only provides a ticket to the buyer who has completed the transaction process first.
Right. I'm pretty sure Sajjan will be most alert and active when we talk about movies. Movie का नाम जहाँ है वो alert हो गया होगा, right Sajjan?
Yes.
अभी लॉकिंग याद रहेगा ना?
Yes.
मूवी का एग्जांपल दे देना. ठीक है. How locking solves the problem of the concurrent transaction? So log-based protocols in DBMS is a mechanism in which transaction cannot read or write data until it acquires a proper lock. Lock-based protocols help to eliminate the concurrency problem in DBMS for simultaneous transactions by locking or isolating a particular transaction to a single user. वही सेम चीज़ है, just the iteration of that. लॉक बेस्ड प्रोटोकॉल में बेसिकली वो कहता है कि लॉक एक्वायर आपको करना पड़ेगा अगर किसी डेटा आइटम पे आपको ऑपरेशन परफॉर्म करनी है. जब तक आप लॉक एक्वायर नहीं करोगे तब तक आप उस पर ऑपरेशन परफॉर्म नहीं कर सकते. This is to avoid that concurrency problem. So there are two types of locks. One is binary and second is multiple mode locks. In binary lock, it has two states, locked or unlocked. So this says that any transaction, if it wants to work on n number of items, it is supposed to acquire the lock on those items at the beginning itself. And when it wants to release the lock, it has to release it together at the end. So for example, T1 को यहाँ पे मान लो काम करना है on X and Y, and T1 wants to so T1 needs to put a lock on both of these guys. Okay, then over here it starts working on it, like reading X, subtracting something out of it, then writing X, which is committing that. In the middle, if somebody else comes in, like T2 comes in and tries to place a lock on X, you can't do that because lock has already been placed by T1, so you can't grab that lock unless this is released. Even though T1 has finished working on X at this point, uh, it cannot release it until all the operation on all the data item is done. So because now it will perform operation on Y, reading Y, adding, writing Y. Now it can unlock X. So now T2 can come and place a request on X, and then it can unlock Y also. So locking and unlocking has to be done together. Locking needs to be done at the beginning of the transaction, and unlocking for all the data item needs to be done at the end of the transaction. So that's binary lock. When you talk about multiple mode locks, it has two locks. One is shared lock and second is exclusive lock. So in shared lock, what happens is that multiple transactions can, okay, let me remove this. Yes. So multiple transactions can acquire a lock on a single item. And why it is allowed? The reason why it's allowed is because in shared lock they can only read, and let 10% read the same data is not going to change, so let them read it, no problem, but they can't write it. So sharing is allowed, but only if you want to read it. Okay, so that is shared lock. So multiple transactions, like for example in this case T2 put a shared lock on X, shared lock on Y, T11 put a shared lock on Y, shared lock on Z. So they put that. So you can put it, but you can't write it. You can only read it. Then you have exclusive lock. So exclusive lock is used for both reading and writing. But the thing with exclusive is that if you put an exclusive lock, until unless you release the lock, nobody else can come and grab it, and you can't share it. You can't share the same data item with others. So that's your exclusive lock. Want somebody to read it, Ashish?
Yeah, sure, of course. So multiple mode logs, it offers two logs. One is the shared logs or read-only logs, you can say. With the shared log, the data item can be shared between transactions. This is because you will never have a permission to update the data on the data item. For example, consider a case where two transactions are reading the account balance of a person. The database will let them read by placing a shared log. However, if another transaction wants to update the account balance, shared log prevents it until the reading process is over. So,
Okay.
and the next one is exclusive lock. With exclusive lock, a data item can be read as well as written. This is
Hmm.
exclusive and can be held concurrently on the same data item. Xlock
Hmm.
is requested using the lock X instruction. The transaction may unlock the data item after finishing the write operation. For example, when a transaction needs to update the account balance of a person, you can allow this on transaction by placing an X lock on it. Therefore, when second transaction wants to read or write, exclusive lock prevents its operation.
Okay, so I think I've already explained both of them in simple words. Key thing to remember is that the word S is used for shared lock. So see S underscore, and then for exclusive lock, X is used. So X underscore wherever the exclusive lock is placed. So here is moving on.
What is exclusive lock? Can you please give a quick
Yeah, yeah, of
explanation
course.
about that? Yeah.
Yeah. So exclusive lock means that if you want to do both reading and writing, then you have to place exclusive lock. You can't have shared lock because shared lock doesn't allow writing. So let me give you
Correct.
example here. Let's say there's a transaction which wants to go ahead and make any changes on the Y. So it plays the X lock, exclusive lock on this. Previous exclusive lock request X is granted, X is unlocked. Okay, so it's unlocked now. Now this is displaying Y and Z. Then this is unlocked. Okay, which transaction is it? One second. This lock is mm, so which transaction is placing the X lock?
And after that, I think read Y and Z. T1.
Here it is, right? Yeah, here it is. T1 is doing that. Yeah, yeah.
Yes, T1.
T1. Yeah, so T1 plays the X log. It started working on it, reading, writing, right? Then it's reading Y, adding, writing Y, then unlocking Y. Okay, so simple thing you have to remember that if you want to do both reading and writing, you have to place exclusive lock. If you want to just do reading, you can do a shared lock, which means multiple transactions can work on the same data item using shared lock. Okay.
Okay.
Okay, let's see next one. Weak identity. So basically entity is your relational tables, like a student table. The student entity is called student entity. Program table called program entity. So um, so you have something called strong entity and you've got weak entity. Strong entity will have its own primary key, which is unique ID, with the help of which you can identify the data item inside of that. And a weak entity will not have a primary ID. It will be dependent on the strong entity. So sometimes let's say that you have student information, and then you have guardian information. So they are two different entities, two different tables. So guardian is a weak entity because it's dependent on student, but student is not dependent on guardian, and guardian doesn't have the its own primary key. So let me give you another example here. Weak entity. Like for example, this there are two entities, loan and installment. So loan has its own ID, primary ID, and loan is the strong entity, but installment is dependent on the loan. It doesn't have its own ID. So that is why installment is your weak entity, and installment weak entity are denoted by double rectangle. Here it is. An entity that depends on another entity is called weak entity. The weak entity does not contain any key attribute of its own. The weak entity is represented by double rectangle. Moving on. We will take a break in terms of doing the theory. I'd like Sumaya to take over on this question. Sumaya, do you think you'll be able to do this question right now?
Yes.
Okay, so I'll let Sumaya take over, and I think it's an important question. But I was thinking before we did this question, why don't you take us through the normalization, first, second, and third, in terms of theory, and then we go to doing this questions that'll make it easier for people to understand. So maybe you can just explain without looking at the slides what each one of them are, and then we'll look at the slides also. So we'll do the first normal form explanation, then we look at the slide, then we explain the second one, then we look at the slide, like uh, in an interleaved manner.
Imran, if you don't mind, can I
Uh,
take it? The theory part. Sumaya, I'm sorry. Like I know you explained it. I already went through that video. So
Okay. Yeah,
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 it's
no
fine.
problem. So Somaya, you go ahead and explain it, and then the same thing will be explained by Ashish on the slides.
thank you. Yeah.
Yeah.
Okay.
So what's the first normal form?
The first a relation is in first normal form if it has atomic values.
Hmm.
Every attribute has atomic values. That means they should not be composite values or multivalued attributes.
Yeah.
Then each column should contain the same data type,
Mm-hmm.
and each row in the table should be unique.
Yep. So the attributes need to be atomic, which means they should not be composite. You cannot break them, and it shouldn't be multi-valued, and none of the rows should be duplicates. Right? The two key things for first normal form. So let's look at normal form. Yes, Ashish, go on.
Yeah. So basically, all columns in the table should be atomic,
Mm-hmm.
atomic value. In other words, like it should meet some conditions. So the first
Okay.
condition is there should not be any duplicate values, duplicate tuples. You can say
Mm-hmm.
in the relation. Like here, the relation word means table. Okay,
Yeah.
and each data value stored in the relation should be fully dependent on the single value.
Okay.
Yeah, there should be a relation between like primary key and the whole row. The second point means, and the third point is entries like and all the data, like all the cells in the column should be of the same data type.
Yeah, I think I missed that. This is the third point, that all the
Yeah,
attributes should be of same data type. Yeah.
yeah,
So atomic, no duplicates, single value attributes, and same data type.
yeah.
Okay, go on.
So this table is not in, like you can see the table, the first table, which is not in the one enough like one normalized form. As the each
Mm-hmm.
attributes of the table must have atomic, like single values. The employee underscore mobile, you can
Mm-hmm.
see the mobile numbers. Like there are multiple those like those types. Those are the data types of multiple values. Like
Yes.
that particular cell contains the multiple values. That's what.
Mm-hmm. Yeah,
So it's not allowed. Like it should be a single value attribute.
correct.
It shouldn't be the multiple value. So to make the table comply with the 1NF, we need to create a separate row for the each mobile number in such a way so that none of the attributes contain the multiple values.
Correct. Cool. Let's go on to the second one. So Sumaya, what's second normal form?
Uh, a table is in second normal form if it is in first normal form, and if there are no partial dependencies, if there are no non-prime attributes with partial dependencies,
So
or
non
every
all.
non-prime
Mhm.
prime attribute is fully functionally dependent on the primary key.
Okay, so non prime attribute should be fully functionally dependent on the prime key attribute, right?
Yeah,
Are there any others, or just that point?
no, that's it.
Okay, that's pretty easy then. Okay. Yes, Ashish, go on.
Yeah, a relation that means a table is in the second normal form if it fulfills the following criteria. The first criteria it should be following the 1NF form. That's the first criteria, and the second criteria is uh, all those attributes which are not a part of any primary key, like non-primary attributes, like non-prime attribute, are fully functional dependent on the primary keys. That should be the case.
Okay,
Key features of the 2NF, the partial dependency will exist only if
let's
the
skip this
primary.
part. It's
Yeah,
confusing. Let's just skip this guy right here.
okay. This
Yeah,
normal
it's too
form,
confusing.
yeah,
Yeah,
yeah, correct.
go on.
Fine, fine. So this table is in 1NF because each attribute has atomic values. However,
Yes.
it is not into 2NF because non-prime attributes like teacher age is dependent on teacher ID alone, which is a proper subset of candidate key.
Hmm.
Yeah. So you can explain it, and then if you want,
Yeah, no, I'll let
it's
Sumaya explain this.
So we have a table with teacher ID, subject that the teacher teaches, and teacher age.
Mm-hmm.
The candidate key is teacher ID plus subject, because we have the same teacher teaching multiple subjects, so we have to
Yes,
have both the attributes in the candidate key.
correct.
Then the non-prime attribute, teacher age, is dependent only on the teacher ID.
Hmm.
So there is repetition of data for each teacher row.
The rule says that all the non-primary attributes which are not part of the primary key are fully functional dependent on the primary key. So it's not fully
Yes, it's
functional dependent
partially
on both.
dependent.
It should be dependent on both of them. Then only it'll be into NF, correct?
Yes.
Okay.
So
Okay.
we remove that partially dependent attribute and put it in a separate table with the teacher ID and teacher age,
Okay.
and uh, the other table is teacher subject with teacher ID and subject.
Okay. Okay. जो एग्जाम के बाद ना जो समया को भुलवा देगा ये ना, उसके लिए उसको मेरी तरफ से ट्रीट है. If anyone can make Sumaya forget about normalization, I'll give them a treat.
हाँ, देखे मैंने वीडियोस सारे.
Yes. Okay, so just a recap on starting from here. So we are doing double recap so that we kind of recall what's happening. So first normal form is the one where the attributes should be atomic and there shouldn't be any multi-valued attributes, and at the same time none of the rows should be repeating, none of the tuples should be duplicate. Was there one more point? Yeah, it should be of same data type. All the attributes should be of same data type. Okay, so example, here there are multi-valued attributes, so you kind of break them into multiple rows, but it's still unique because each of them are not exact same copy of another tuple. In second normal form, basically you have to follow the first normal form, and also at the same time all the non-functional, non-prime attribute, which means attribute which are not part of the primary key or the candidate key, should be fully functionally dependent on the primary key attributes. So give you an example, these two make the make candidate key. So you can see here teacher ID plus subject make candidate key, and the rule says that anything that is not part of the candidate key should be fully functionally dependent on both of these, right? So teacher age is not part of candidate key, so this is my non-primary attribute. So this should be dependent on both of these guys, but in this case we can see it's not dependent. Like age is not dependent on mathematics has no relation to age, physics has no relation to age. It is dependent on teacher's ID because we're talking about teacher's age, right? So it is dependent on one, but it's not dependent on the second one. If this would have been teacher's name, then yes, probably it would have been dependent, but because it's subject, it's not really dependent. So it's not following that rule. So what we do, we kind of break it. So we break the teacher ID and teacher age into one, and then teacher ID and subject into one. So now subject has to dependent on teacher ID because if I just put subject, it needs to have some kind of an ID to go with. So it is dependent now. Cool. So that's what is okay. Let's go with the third normal form. So of course it has to follow the two. It has to be in 2NF, and what was it? Transitively dependent. I don't know what that was. I don't remember. Sumaya, can you recall that? What was it?
No transitive dependencies.
Of what?
Primary key.
No non-prime attributes should be transitively dependent on the primary key.
So they should be directly dependent, right, on the primary key.
Yes.
Okay. Yeah. Go on, Ashish.
Yeah, a relation is in a third normal form if it is in second normal form, and every non-key attribute of the relation is non-transitively dependent, like direct dependent, and can be directly derived from on the primary key of the relation. In other words, a table is in third normal form if it is in second normal form, and for each functional dependency like x derives y, at least one of following condition is true. Like x is a super key of the table, y is a prime attribute of the table.
Okay. Okay. So explanation. Sumaya, can you explain this part? It's a little complicated.
So we have an employee table with employee ID, name, zip, state, city, and district. The candidate key is employee ID, and all of the other attributes are dependent on employee ID. So it's in second normal form. But we have a dependency from state, city, district. They're all dependent on the employee zip. And the employee zip is dependent on employee ID. So this is a transitive dependency. It's not direct. So we have to get rid of the transitive dependency. So we remove all of those transitively dependent attributes, state, city, district, and put it in a separate table, employee zip table with the employee zip. And and we have our original table, employee table with employee ID, name, and zip. So now it
Was there a
complies with
requirement?
3NF.
Yeah, was there a requirement of putting zip here? We already put zip here, right? So was there a requirement to put zip?
Yes,
It's a
because you have
foreign key
to be able to.
reference.
Yeah.
Sorry,
Foreign key reference.
primary and foreign key.
Yeah.
Yeah,
Okay.
you should be able to join these two relations to get the original relation. So we need
Lossless join.
the reference.
Lossless join.
Yeah.
Okay, fine. So so basically, third normal form means it has to be in 2NF, and all the non-prime attributes should be non-transitively dependent, which means directly dependent on the primary key. In this case, it is not because state, city, and district are dependent on zip code. So we break it into two parts, which is employee ID, employee name, and employee zip code. And of course, we have to maintain the primary key and the foreign key relationship. And we put all of these guys who are dependent on the zip together. So these guys also happy, and this is also happy. Okay, so moving on. Now let's do this example. And so may, if possible, do it in a way that we should do in an exam. Yeah. So I'll stop share, and you can share yours. ये सज्जन फिर निकल गया इधर से. सज्जन कैसे ड्रॉप हो जा रहा है? By the way, if I forget to tell everyone, then all the best for your exam. For those I will not see tomorrow, especially Ashish and Sajjan.
Yeah, same to you, bro.
All the
Yeah.
best, everyone. Even even you won't see me. I'm in Bangalore, so
Oh, oh my
yes,
God. All the best, but
yes, all the best.
अरे
cool.
हमने फॉर्मूलाज नहीं किए जो हम करने वाले थे आई थिंक
क्या
कुछ इवैल्यू सम्स थे ना
करेंगे ना
न्यूमेरिकल
कर, करेंगे so how we are planning is like we do theory and then we do some sums, we do theory and then we do sums, because that way we won't get tired. Theory भी important है, sums भी हैं, theory भी, everything is important. So we did start with the theories that we didn't spend too much time yesterday on. Okay.
Okay, you can see my screen.
Mm-hmm.
So we have the relation R with attributes A, B, C, D, E, and the set of functional dependencies. A determines B, C, B determines E, and C determines D.
Hmm.
So to find the key in R, the first thing we have to do is uh, find the attribute that can determine all the other attributes in the relation.
Mm-hmm.
So that's called the closure of the attribute. So let's find the closure of A.
A plus.
Yeah. So A determines A, that is trivial. And then we have BC from this functional dependency.
So from A you can derive B and C.
Yes. Maybe we should explain this a bit while writing. Like A
Yeah.
determines B, B, C. This implies A determines B and A determines C.
Okay.
And then we have B determines E, and we can derive transitively because A determines B and B determines E. That means A also transitively determines E,
Okay.
and then C determines D. So in the same way, it transitively determines D as well.
So what are you trying to
So
say that
A,
from A you can derive all of these guys, B, C, D, E, all of them. That's
yes,
why A is your what key?
it's a candidate key.
Candidate key. Okay. And what's that plus sign you said?
Closure.
Closure. Okay.
So A is the candidate key. Next, we have to decompose R into 2NF and 3NF.
Mm-hmm.
So the candidate key we have here has only one attribute. So there's no question of having a partial dependency. All these A, B, C, D, E are fully
Candidate.
dependent on A. So it's
Yeah.
already in 2NF.
Okay.
Then we have to decompose it into 3NF.
Yeah, so we
So
already got 3 points because we found the key as A, right? Key in R means we wanted to find the candidate key, correct?
yeah,
Okay, good. And it's already in 2 NF you said. Now we have to do in 3 NF.
yeah.
Okay.
So it's not in 3NF because we have these transitive dependencies. D and E are not directly
Not
dependent
directly
on A.
dependent. Correct.
Yeah.
Correct.
So you just have to make a separate table for each of these.
Okay.
So we have one table R1 with A, B, and C. and R2 with B and E, and R3 with C and D. So all those three relations will be in third normal form because you won't have any transitive dependencies. Next to each relation, you could write the dependency that you uh, derived it from, like from A determines BC.
So relation one is A, B, and C, and you derived it from A determines BC, correct?
Yes,
And similarly, we have to write it for the other one. So R2, will it be R2? And
yes,
then brackets B comma E, and we derive it from B determines E. So
yes,
will we write it
and
as R1, R2, R3 for each one of
yeah,
those?
yeah.
Okay. We don't have to draw any table or anything. We just have to write it like this, right?
No, there's no need to draw tables.
Okay. I don't know why they've given so much marks then 5 marks for that.
You might need to write the explanations like
No.
why it's already in 2NF and why it's not in 3NF, and then decompose it.
Yeah, we have to do that, right?
Yeah,
Okay. So yeah, you already explained, so we probably don't have to write it.
yeah.
But we'll write in the exams. Okay, moving on. Share screen. So we're going backwards. So we did this whole thing, and we're doing question number 4. And these guys, we didn't spend too much time yesterday on, so we'll do these guys. Data recovery. So does anyone remember what data recovery is? We spent quite some time yesterday. I'll let you guys say it first. Okay, so data recovery basically means that in case if the data is lost due to um, system failure or some natural calamities, the hardware failure or virus and all of those things, then we should be able to retrieve that data. And there are certain conditions for that. For example, we should be able to retrieve the data in an efficient manner with minimal cost, and we should be able to lose we should lose minimal information when we are trying to retrieve the data. So we'll go to the slide. Recovery. So data recovery is the process of restoring the data that has been lost, accidentally deleted, corrupted, or made inaccessible. It ensures that data is reliable and remain in consistent state in case of a failure. What's a need? When a system crashes, it may have several transactions being executed on various files open for them to modify the data items. This crash could be because of software, virus failure, hardware, external natural calamities, etc. Aim of recovery scheme to allow database operations to be resumed after failure with minimum loss of information and economically justifiable cost. I remember these guys because we had a kind of discussion on this. So anything that we discuss, it's high chances you'll remember in exams. Okay, I'd like Sajjan to read this.
Okay. What is data recovery? Data recovery is a process of restoring data that has been lost, accidentally deleted, corrupted, or made inaccessible. It
Mhm.
ensures that the database is reliable and remain in consistent state in case of a failure. Mix of data recovery. Yeah. When system crashes, it may have several transactions being executed and various files opened for them to modify the data item. This crash could be because of the software, hardware, or external failures.
Okay.
The aim of recovery scheme is to allow database operation to resume after a failure with the minimum loss of information and economically justifiable cost.
Right. Okay. Kritika, now do you remember any points?
Um, on how it is done.
Any? Give me one point about data recovery.
Data recovery can be done in three ways. The first one, oh, do you mean the one that we okay.
Yeah.
Uh, it should be done in a with at an economically justifiable cost with a
Mm-hmm.
minimum data loss.
Mm-hmm.
It is a process of recovering data if something like disk failure has happened or a natural calamity or um, something like that has happened.
Cool. Sounds good.
Yeah.
So Maya, do you remember anything?
Data recovery is the process of restoring the database to a consistent state in case of a failure or error.
Okay. Okay. Ashish?
Data recovery is a process of recovering the data in case of any failure occurred due to the system failure or OS failure or any natural calamities. And the question
Okay. Awesome. Okay.
The
Moving on to
cost
the
should
next.
be justifiable. One point.
Yes. Yes. Economical justifiable cost. Good one. Okay. So restoring data that has been lost, accidentally deleted, corrupted, or made inaccessible. It ensures data is reliable and in consistent state in case of a failure. When system crashes, it may have several transactions being executed and various files open them to modify. So, for example, user is already working on that data. Several transactions are being executed. He has opened different files to modify the data items, and all of a sudden the system crashes. This crash could happen because of software, hardware, or external. Software could be virus or operating system failure. Hardware could be disk failure, and external could be natural calamities. And the main aim of data recovery is basically to allow the database operations to be resumed. So let's say some people who are working on that data, and then because it got crashed, we want to be able to resume those operations. And in one what state? There should be minimal loss of the information, and it should be economically justifiable cost. How it is performed? It is performed with control Z and control what? Control V.
Control Z,
Z.
which backward recovery.
And there was a
Control
log. There was
Control
a
Y,
log also. Yeah.
which is forward
Forward.
recovery, and then there
Mm.
is log based recovery, which is like making a copy of it and keeping one as a backup in a stable source in a
In
stable
maybe
way.
in a hard drive, maybe in a persistent storage.
Yes, yes, stable storage. Yes, right.
Yeah, so you remember all these things because you remember the control control Z and okay. So following techniques are used for recovering as well as maintaining the atomicity of the transaction. Backward recovery is like undoing something. Like when you type something on with the keyboard and you do the control Z, you kind of undoing that thing, right? So uncommitting the changes are undone. Basically, instead of system is reset to the previous consistent state, which was free from errors. Okay, so uncommitting changes are undone. Uncommitted changes. Then forward recovery, which is redo. In this scheme, committed change are reapplied. So let's say you performed a transaction, you made the change to the data, you written it, you committed it, and now when you were doing the second transaction, next set of transaction, the system fails. So what you want to do is, of course, the second transaction will be lost, but the last point where you had done the commit, you can recover from that point. It's just like when you're playing a video game, you save your progress. So even if the electricity goes, power failure happens, you will of course lose anything that's not saved, but you'll always be able to recover from the checkpoint where you saved. So that's what it's talking about. In case of failure, get reapply the committed changes so you can recover from till the point commit was done. Then you have maintaining logs and writing onto some stable storage before modifying the database. This is an example. The log keeps track of all the transaction operations that affect the values of the database items. This information is needed to recover from transaction failure. Transaction is initiated, write start log, T start. Transaction modifies the address from Pune to Mumbai, T address Pune, Mumbai. Transaction is completed. Log indicates the end of the transaction. T commit, assume at the point of time failure, at this point of time a failure occurs. Transaction is committed, we have to perform redo for recovery. So try to remember this because you have to give example. Transaction initiated, write start log, T start, transaction modifies address from Pune to Mumbai, T address completed, T commit. Ashish, you want to go over this once again, this example?
Yeah, like the log keeps track of all transaction operations that affects the value of the database item. This information is needed to recover from transaction failure. So the first log will be the transaction is initiated by start log. It will say the T1 start, T1 comma start,
Mhm.
and then we have a modification. Like transaction modifies the address from Pune to Mumbai, so it says T comma Pune comma Mumbai. Okay, T comma address comma Pune comma Mumbai. Correct. Then the transaction is completed. The log indicates the end of the transaction. That means a T comma end. Oh, T comma commit. That's
Commit, you
good.
have to commit it. Hmm.
Okay, we commit it. Okay. Log T comma commit, and then assume at this point of time a failure occurs. Since the transaction is committed, we have to perform the redo for recovery.
Okay, cool. So now we'll do this one after doing one of the problems. So Maya, will you be able to take this guy writing the query statements? I've already prepared the table for you, and then maybe if you can, I'll share this with you. Maybe you can just write the query. I'll put the questions also.
Okay.
Okay, so we have the account. Is that account the first one? And then you have two relations, account and bank. And account number, name, and balance. These are the three attributes. Okay, I think it's not a good color. Let's keep it to something light. Okay, and then you have the branch code, phone number, and account number in the next one. Okay, let me share that with you. Should have copied link. I don't know if it got copied or not, but you got it.
Yes.
I'll stop the share.
Where are the questions?
I put the question there. Didn't get saved or what? Maybe it didn't get saved. Can you see now?
Yeah.
Okay, good. The first question
Uh,
is list all the account numbers in order of their name.
yes, so we need to do select account number,
Mhm. One question,
and
Sumaya,
we
why are they putting hyphen in the attributes names? And if they are putting
uh,
hyphen in the question, then are we supposed to use hyphen? Are you supposed to use underscore? Uh, because I don't think hyphen works in when creating columns.
yeah, hyphen doesn't work, so there must be
So
a
like,
mistake.
so when we write the answer, should we put hyphen or should we put underscore? I'm a little confused.
Yeah, I think we can put underscore. I don't think it matters much.
Okay, cool.
So we can display the name as well because we're displaying in order of name. Select account number, name from account,
Mm-hmm.
order by name.
I think
So this,
we should put all those attributes into double quotes. No.
No, 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 no. Because we are not running it in the code. We're just running it on a maybe on a SQL query terminal or maybe in
Okay.
some
Okay. Yeah.
workbench. I will put this into the real SQL query uh, tool and I'll show it to you also once Sumaya finishes this.
next we have find the account number which has the highest balance.
Yeah.
So we'll select account number from the table,
Mhm.
from account, and order in descending order by
Yeah.
balance,
Mhm.
and print only the top row. So limit
The limit one.
1.
Okay.
Next, we have to list the branch code, account number, name, and balance of each account. So here we
Mm-hmm.
need to join these two tables.
Mm-hmm. Inner join, right?
Yes, this join
So
will work.
select. Okay.
Select
List branch,
branch code.
branch code, account number, and name.
For account number, you have to specify the table also because both the tables have the same name, the same column name.
Are you sure? You have to specify?
Yes, I think so. Otherwise, it shows an error.
Okay.
You can create also alias if you want.
As
As account number. Yeah.
okay. Ashish, you seem to be more familiar with the database queries. Have you worked on it?
Yeah. Yeah. Like I'm in my current project, I'm working on it. Yeah.
Very good. You'll score all marks, full marks then in that case.
Many भाई.
Yeah, इसमें ये है कि they can't deduct your marks. On the theory they can. Here they can't. If you put the right
Yeah.
query, you'll get full marks at least from this question.
Correct. Yeah.
Inner join and
So
join is
from
same, right? Sumaya?
a yes, from account join bank on account number.
Equals ban dot account number, right?
Yeah. And that's it, right?
List branch code, account number, and name and the balance of each account. Yeah, that's it. Last one is a little tricky.
Find the number of accounts in each branch. Uh,
Hmm.
so we have to count how many times each branch code appears in this bank table.
Okay.
So select account branch branch code from the bank table.
Mm-hmm.
And then we have to group by branch code. We have to group the same branch codes together.
And do we not have to use anything called distinct? What if the account numbers are repeated? Will it ever be repeated?
Um,
I don't
no,
think so. No, because it's a foreign key. So it will,
Are we just then in that case just counting the number of rows, the number of pupils in the bank table?
are we counting the number of rows that have the same branch code?
Okay. So what if the branch code is like multiple accounts have the same branch code? How are we making sure it's distinct?
Um, that's what we're counting, right? If
No,
multiple
we
accounts have the same branch code.
find the number of accounts in each branch. Okay. Okay. Group by branch code.
Oh, and we should also print the branch code. Select a branch code.
Couldn't we have done count of account number instead of count of branch code?
No, we have to count the branch code.
Okay.
The
we have
branch
to
code will
count
be
the
duplicated.
number of accounts per branch. Like let's say for the
Right.
1, 2, 3 branch, let's say we have a three accounts, so there will be three tuples. Okay, three rows.
So branch
So we
code
need
will
to
be that.
group. Yeah.
Yeah.
So for
Branch
that,
code will be repeated thrice.
1, 2, 3. Yeah. So it will be repeated thrice. Okay, if you say count, just a normal count, and when you're writing a group by with branch code, and what it will
Mhm.
do, it will group by all the records for individual branches. Let's say for 123, if it has three account numbers in it, then it will group by all those account numbers. It will conclude the count of that 123 branch to three.
Okay, that's fine. So I'll just run this query. I'm going to share my screen now. Okay, so first this one. So I already have the account and bank table. Okay, you guys can see my screen, right?
Yeah, yeah.
So select account number. It's good to break it into multiple lines. So select account number, name from account and order by name. Let's see if we can get that. Okay. So yes, you're getting that. Then we'll go to the next query. Select account number from account, order by balance in descending order, limit 1. I should get the highest one. So I've got 2, 3, 4, 5, 6. Let's see if that's the highest. 2, 3, 4, 5, 6. That's 30,000. So yeah, yes, that's the highest. That's good. Go next. SQL. To select branch code, count the branch code as number of accounts from bank and group by branch code. See, show query box. So 123 has one account, 321 has one, and 543 has one. Yep, perfect. Cool, sounds good. This was a bit tricky, at least for beginners. So Ashish, when do we use group by actually?
When you wanna group all the records based on one key. Okay, here the key is branch code.
Mm-hmm.
Okay, so let's say if we have three record, let's say in the bank table, if you see the branch code, let's say if there is a repeated rows with that particular branch code, 1, 2, 3,
Yeah,
and if you
yeah.
wanna group, if you wanna group all those records with that particular branch code 123. In that case, the branch code column will become a key for the query,
Mhm. Mhm.
and it will work like as a group by function, the normal group by function.
Excellent. So now, thanks, Ashish.
Yeah.
Now we'll do this one, which is query optimization in context of DBMS. Query optimization. Okay, query optimizer uses two techniques to determine which process or expression to consider for evaluating the query. First is cost based optimization. So that's physical, and this is based on the cost of the query, which relates to the time it takes to execute the query. The query can use different paths based on the indexes, constraints, sorting methods, etc. Method mainly uses statistics like record size, number of records per block, uniqueness of column values, size of the columns, etc. And the second one is heuristic or logical. This is rule based optimization. This is based on the equivalence rule on relational expressions. Hence, the number of combination of queries gets reduced here. So, the cost of query is also reduced. This method creates a relational tree for the given query based on the equivalence rules. The most important set of rules followed are perform all the selection operation as early as possible. This should be the first and foremost set of actions on the table in the query. By performing selection operation, we can reduce the number of records involved in the query rather than just using the whole table throughout the query. So if you remember, we when we were doing the query, we were actually putting the names of the columns, which is the attributes. We are not using star here. Using star, we are kind of displaying all of the attributes or the columns, which is not really required. If you need only two, then just put two. So that's good for query optimization. It'll take less time. Okay, Sumaya, can you read this?
Query optimization with examples. The query optimizer uses these two techniques to determine which process or expression to consider for evaluating the query. Cost-based optimization, physical. This is based on the cost of the query. Cost relates to the time it takes to execute the query. The query can use different paths based on indexes, constraints, sorting methods, etc. This method mainly uses the statistics like record size, number of records per block, uniqueness of column values, size of columns, etc. Heuristic optimization or logical rule-based optimization. This is based on the equivalence rule on relational expressions. Hence, the number of combination of queries gets reduced here. Hence, the cost of the query to reduces. This method creates relational tree for the given query based on the equivalence rules. The most important set of rules followed are perform all the selection operations as early as possible in the query. This should be first and foremost set of actions on the tables in the query. By performing the selection operation, we can reduce the number of records involved in the query rather than using the whole tables throughout the query.
Okay, so Sumaya, give me 1 point for the query optimization.
Um, so, one method of query optimization is cost based optimization.
Mm-hmm.
So, to evaluate the query optimizer tries to reduce the cost by using statistics like the number of records and the number of records in the table, the number of records in a block, the uniqueness of
Mm-hmm.
column values.
Okay. Okay, good. Ashish, can you read this?
Yeah, the query optimizer uses these two techniques to determine which process or expression to consider for evaluating the query. Cost based optimization, like physical. This is based on the cost of the query. The cost relates to the time it takes to execute the query. The query can use different paths based on indexes, constraints, sorting methods, etc. This method mainly uses the statistics like record size, number of records per block, uniqueness of column values, size of columns, etc.
Okay. So give me 1 point on the query optimization. Just whatever you recall, it's fine.
Okay, so the query optimization is, I think it is done based on the time.
Yeah, correct.
Like, I don't remember exactly. Sorry, I read first time.
No, no, it's completely fine. See, think about it. Like logically, if you're writing a query for your company, and if there are large number of records in your company, right? So
It's based on the cost. Okay,
yeah, so the time
based
it
on the
takes.
cost and the time it takes to execute the query.
Correct. So how will you ensure that less time is taken? How will you ensure when you write a query?
Like
How will
there
you make
is
sure it's efficient?
like usually the query takes its own. It runs based on own constraints, sorting algorithms, and the select query. So we should it should take less number of time to access all the records.
Correct. So basically, it talks about two approaches. One is related to cost, and second is related to the heuristic approach, which is the rules we follow. So when it comes
Correct.
to cost, we're mainly talking about the time it consumes. So when we're writing the query, we have to think about how many records are there in the database, what's going to be the impact. For example, in one of the examples that we just looked at, which was this one, it asks us that give me the account number which has the highest balance. Okay. So here, of course, there are a lot of records in the system. And sometimes when you want to pull it in the function, you know that if you get the data in form of an array, you can pull the first item. So if you are going to pull all the data, all the records, you don't really need that. All you need is just the first one because you're putting in descending order, right? So someone could also do something like order by in the ascending order and get the last item in the array. But then you are pulling all the data, and then think about it. If the number of records are like really large, imagine the time it's going to take to execute that query. So if you don't need that much of data, then you might not get that. You shouldn't get that much of data. You should put the limit of one. So these are the things you should consider. And then when you talk about the rules, so rules like as I explained, instead of putting star and getting all the attributes, you just get the ones you want. Okay, so record size, number of records, these all things you have to keep in mind. Look at your database and see how many, what's the size of the record, what's the number of the record, how many records are there per block, what's the uniqueness, size of the columns. So all of these things should be considered when writing the query. That'll take less time to execute. And then this guy talks about the rule to reduce the query execution time, performing all the selection operation as early as possible. This should be the first and foremost set of actions. And performing selection query, we can reduce the number of records involved in the query rather than using the whole table throughout the query. Okay, so in the exam, just think about how you can optimize the query. Basically, how can you make sure that your query that you write is efficient and to the point. We'll end at 11:30 because I would like everyone to probably sleep and stay fresh tomorrow. So we'll take 10 more minutes and then we'll sleep. I mean, whoever wants to go to sleep. So now we'll go. I think we missed one thing. We didn't do the example, right? We have to do example also. Let's see what we have in the example. Yeah, a simple example. Like here, Selection of rows that are required instead of selecting all the rows should be followed. This is the simplest example. So select all is highly inefficient as it scans the entire database using star. Select all. Star means all. See how many. So see what's happening here. How much time it's taking? 125 milliseconds. Versus if you just need product number, name, color, weight from whatever table, this takes only 41 milliseconds. So this almost 60% of the benefit in the cost of the query, which is the time it takes. So that is why when you write queries and look at the time it's consuming, because if you take more time to consume, that is going to take that much time in rendering that page. So when you're dealing with PHP, when you're dealing with databases, when you're making a query, sometimes the page loads really slow. And why? Because it is data heavy. It requires a lot of data. It needs to do a lot of calculations, and is going to take more time to render because it's taking time to get that data. And why it's taking time? Because somebody used star over there. Okay, so imagine there were 10 query, imagine there were 10 elements on that page using, and everybody using star on that. So multiply that 125 millisecond into 10 or 20 maybe, depending on how much data is there. So it'll just keep adding to that. So that's what you have to remember, and that's what is your query optimization. So it's the simplest example. um Okay, so we did this. We already done the normal forms, which is great. Um, Lossless join. Sumaya, did I probably request you to add the lossless join example yesterday? Do you have a chance on that?
Yes, there is an
Already?
example already.
Okay. You put the whole thing, right? Good.
I didn't put it.
It's already there. Okay. If the information is not lost from the relation that is decomposed, then decomposition will be lossless. Lossless is going to guarantees that the join of the relation will result in the same relation as it was decomposed. Okay, so this is an example. Upper relation is decomposed into two relations, employee and department. And the club of that is going to give us the same thing. So just simple thing you have to remember. We spoke about normalization. Why we did normalization? Because there was duplication of the data. The data was not atomic, uh, and there was functional dependencies. Sometimes data was not directly dependent, so we broke it into two parts. What this is saying is that if you broke it, if you decompose it in two tables, if they come together, will it give me the same table as it was original? If yes, then it's called lossless join because I'm not losing any data. Okay, then normal form, advantages of database management system, use of primary index, secondary index. Yeah. Let's do primary index and secondary index, or just indexing. Who still has energy left? Who can read? I know you guys must be tired because I am also tired. Everybody's dead? Hello?
Can you hear me?
Yeah, I think you were out. Sajjan is gone to sleep. You must have gone to watch.
Yes,
Are you there?
yes, I'm here.
Can you hear
सज्जन
me?
कल एग्जाम
Hello.
देना है. या आई कैन हियर
मैं
यू.
आधे नींद में हूँ.
पता है मुझे, मैं भी नींद में हूँ, मेरा मन नहीं कर रहा पता है, क्योंकि मुझे पता है कल एग्जाम देना है. We'll do last question and then we'll call it a night.
Okay.
Okay, so yeah, Ashish, go on.
Yeah. So indexing is used to optimize the performance of the database by minimizing the number of disk accesses required when a query is processed. As an example, a book has a table of content to find them easily, just like an
Yeah.
index. The
Yeah.
index is a type of a data structure. It is used to locate and access the data in the database table quickly.
Hmm.
Indexes can be created using some database columns. The first column of the database is a search key that contains a copy of primary key or a candidate key of the table. The values of
Hmm.
primary key are stored in a sorted order so that the corresponding data can be accessed easily. Correct. Yeah.
Yeah.
The second column of the database is a data reference. It contains a set of pointer holding the address of the disk block where uh, the value of the particular key can be found. Okay, like grouping हो गया
Okay.
फिर
Just
उसका location. हाँ.
yeah, just a quick recap. Basically, we want to minimize the number of disk accesses in the query. Okay, so it's used to optimize the performance by creating an index. How is an index created? There are two columns. First will contain the search key. This search key could be primary index or a candidate key, and it's always in the order. When we are dealing with the primary index, if you're dealing with secondary index, then it's not necessary to be in the order. Then we have the data reference, which is basically the pointed address for that particular block where that particular data resides. And there are two types of, mainly two types of, there are others also, but mainly two types of indexing. One is primary indexing and second is secondary indexing. In primary indexing, the search key is always in an order. And then there are two types. One is sparse and degs. In sparse indexing, each of the primary index has um, has a data pointing to the record in the main table. So, and it consumes a lot of space also, because for every key there is a record. But in the no, that's the dense index. But in the sparse index, the data reference points out to a block in a gap, so it doesn't point out to each and every record there. And then you have secondary index, which is basically going to have, let me just see what that is quickly. Do. Yeah, it's a file that contains the secondary index field value and the pointer to the block that contains the data record. Where is the example? Where did the example go? Mm, which slide is the example? Indexing. Yeah, this is the one. Two indexes were created. Why can't it find it? Secondary index. Okay. Q&A. Did we remove the slide? Can't find it. Maya, do you remember the answer of this question? If two indexes were created in database on primary key and the other on secondary key, which of the two indexes will be of more advantage with example?
Yeah.
Okay, can you explain? And then we'll call it night.
So the secondary key will be of more advantage because if you're searching on primary key
Mm-hmm.
uh, and you don't have the primary index with you, you can still perform binary search because the primary key in uh, mm, the database is stored in the order of the primary key, so you can
Mm-hmm.
perform binary search on the database. But if
Okay.
you don't have the secondary index, then you have to perform sequential search on the database. That takes a much
Okay.
longer time.
Okay.
And with the secondary index, which will be ordered, you
Mm-hmm.
can perform binary index on the secondary. You can perform binary search on the secondary index, and then get your record, and that's much faster.
Okay. And what will be an example? Yeah, we can give example of the book.
Yeah, the table of contents is the primary index, and the index at the back is the secondary index. I think
Right.
I accidentally deleted that slide. My cats are
Yeah,
on the keyboard.
I don't know if we can recover that, but yeah, it's fine. Uh, I don't even think I'll go back. I'll probably use your example, which is
Yeah.
a book. If a book has a table of contents, which is at the front of the book, uh, even if it doesn't have it as a primary index, you can still find it using the binary search if you know the name, the title, or the page number. But if you want to search something by keyword, you can't do that if you don't have the secondary index, because there could be multiple instances of that particular keyword in the entire book. So sometimes you have glossary at the back of the book. What is that table called, like at the back of the book?
It's called an index normally, right?
Index only. Okay. Yeah. So generally you have glossary, you have keywords there, and then it also gives you the page number and stuff. So you can go and check it over there. And usually it's in alphabetical order, I believe. And then you can perform the search. Cool. Awesome. All the best, everyone. I think we have covered most of it. There's just few questions we might not have covered today, but we've covered yesterday. So yeah,
Have
do
you
well. Just
guys already solved in sum yesterday?
which one?
A sum which comes in exam.
You talking about this guy?
Oh, the
Which
sum,
which, which sum are you talking about?
like the problem sum. Like, is there
I
any
don't see any
sum?
sum here. No, I mean I haven't seen any sum.
Is there any
Sum.
formula like which Sajjan was
No,
talking
no,
about?
no. See, this is the whole paper. So generally, this is what is repeated. So you have your first question where they talk about drawing a ER diagram,
Uh huh.
and then you
Okay.
have the query writing. You have to write the queries, and the
Mm-hmm.
last one where they ask you to solve is this guy, which we did today.
Okay. The normalization
Consider.
of form. Yeah.
Yeah, that's it. There's nothing else. Even if you look
Okay.
at the uh, paper, like assignment, there also you don't have anything else.
Mm-hmm.
Okay, so my suggestion is just do the paper and just do the assignment. That's it. Just do those two things, revise them. I think we've already covered a lot today. Just revise it, but don't spend too much time in learning, because otherwise you may forget even what you've learned. Because you have to keep your mind free at least 2 hours before the exam. You should not be looking at the book. You should leave the book at home. I know some people study till last moment, but I feel that you should, for your mind to be able to recall, you should keep it free, especially on
Yeah.
the day of exam.
Okay.
Okay, all the best. We'll meet tomorrow at 9, and we'll discuss how was the paper, and we'll probably party if the questions were from what we prepared.
Okay.
Otherwise, we'll just
Imran,
be.
can you be on the call after you end the streaming
Yeah, 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 yeah,
just for a
sure,
minute?
no problem. I'll end the
Okay.
stream.